Don't forget to subscribe and ring that bell.
What an absolute glorious day to do some mathematics. Nay, to do some calculus. And we are going to continue the 2014 AP Calculus AB practice examination. Thank you, College Board. We are going to start section 1, part B. We are going to do the first 9 of 17 problems right now. I will post another video to do the last 8 questions, which would be 85 through 92. We get a graphing calculator. Woohoo! That's sweet. And in case you're wondering, I use a TI-84 Plus CE. They're sweet calculators. I like the color function and graphing. It's awesome. Put some links down below in the description if you're interested in buying one. Yes, I own one, the mint green one. It's cute, I know. And I have a class set for my classroom. I just love these calculators. All right, let's start, friends. Number 76, a particle moves along a straight line so that at time t greater than 0, the position of the particle is given by s of t. The velocity is given by v of t, and the acceleration is given by a of t. Which of the following expressions gives the average velocity of the particle on the interval from 2 to 8? This is a problem that does not require a calculator. But I tell you what, I almost made a mistake when I first read this problem, and I'm going to point out what I almost made the mistake about. Average velocity. I get my mind so wrapped around average value. Okay, average velocity in this case does not equal average value. Remember, if I want the average value, I integrate for my bounds from A to B, and I multiply by 1 over the difference. Okay, and look what choice A is. It's just that. I almost wanted to circle choice A, but we're not talking average value, so I don't want that. I want the average velocity. Okay, oh, let's get the highlighter. I want the average velocity. Okay, isn't velocity the derivative of position, which is basically the slope? And if I want the average slope, I need 2 points. It's not the derivative. The derivative is the slope at 1 point. But the average slope is basically change in y over change in x. Okay, so don't make that mistake just because it says the word average here. And if I want the average slope of position from 2 to 8, this right here represents change in y over change in x. Now, in calculus, I know we say f of b minus f of a all over b minus a. But it's really the same thing, all right? Don't fall for that trap. This is like a trick question. Number 77. If the sine of 1 over x squared plus 1 is the antiderivative of f of x, then the integration from 2 to 1 of f of x dx is. Let's set up what they gave us, and it will make this problem so much more simpler. If the sine of 1 over x squared plus 1 is the antiderivative of f of x, okay, well then find out this from the bounds 2 to 1. So if I get this as a result of my integration, I just need to plug my bounds into this equation. So I'm going to end up with, okay, and let me state this again, from 2 to 1. That's all I'm doing here. So I'm going to take the sine of 1 over 2 goes into x first, minus my lower bounds going into this equation. Yep, that's squared plus 1. And I'm just going to put this in our calculator, okay? So let's view a detached LCD in case some of y'all are on some smaller devices. All right, so I'm going to hit alpha y equals enter. Oh, actually, first I want to hit sine. I'll be okay. Alpha y equals enter. And it's 1 over. First, I'm putting a 2 in. And that's plus 1. That's my upper bound in there. Now I got to subtract the lower bound. 1 over, this time it's a 1 in for our x, plus 1. Let me make sure that looks correct, and it does. Yeah. I hit enter. Okay, negative, I'll drop this right here. If I round this to 3 places, because all of my responses are 3 places, this 0 will become a 1. Negative 0.281. Choice A. You know what? Like these types of problems. I like them a lot. And if you've seen any of my other videos, you'll know that I love graphs and tables and charts. And instead of giving us a graph, table, or chart in the problem, our graph is a solution, which is great. I love it. Okay? So 78 reads, the function f is differentiable and increasing for all real numbers. Okay? X. And the graph of f has exactly 1 point of inflection. Of the following, which could be the graph of f prime, the derivative of f? All right, so let's take a look here, and let's kind of interpret what they gave us in this problem, and that will absolutely help us choose a solution here. The first thing is f is differentiable and increasing. Okay, it's increasing for all real numbers. That means my first derivative always needs to be positive. If f is always increasing, that means my first derivative has to be positive, okay? Now, all of these graphs below, A through E, are the graph of the first derivative, which means the y-axis is now the first derivative. I should put an equal sign. I shouldn't cross it out. Okay? So if my first derivative always has to be positive, that means my y value should always be positive because the first derivative is the y value. So let's take a look. Rule of thumb on a graph, anytime we're above the x-axis, my y value is positive. And anytime I'm below the x-axis, my y value is negative. These would represent negative y's. But guess what? My y, or my first derivative, should always be positive. So any graphs that dip below the x-axis, any graph that have a negative y can't be an answer. Boom, no. Look at choice D. This is below the x-axis. No. Okay, choice C. This is below the x-axis. No. So right now, it's between A and E. Let's read a little bit more of our problem, or interpret it. And the graph of f, so I'm right here. And the graph of f has exactly 1 point of inflection. Okay, a point of inflection is second derivative. That's when the second derivative changes. So my second derivative changes. But it changes once because exactly 1 point of inflection. The second derivative is the slope of the first derivative, okay? That means the slope of my first derivative should change once. Let's take a look at A and E. And if you're good at this, you should know the answer already. Let's take a look at E. Okay, I'm going to scroll down here. My slope should change once. That's a positive. Comes down here for a negative. Oh, that's 1 change, but then it changes again to positive. That's 2 changes. It can't be this one. Okay, let's take a look at A and just confirm it. Negative slope, that's all negative. This is positive. There you go, that's 1 change. Boom, that's it. Now, please, please, please do not fall for this. Differentiable everywhere. Yeah, the graph of f is differentiable. When you look at this, you might say, that's a cusp. I can't take the derivative there. That's fine. Because that's not the graph of f, that's the graph of f prime. They're telling you the graph of f. is differentiable everywhere. So my graph F doesn't have any corners or cusps. F prime can. And your answer is choice A. Number 79. A vase, or a vase, depending how sophisticated you are, has the shape obtained by revolving the curve y equals 2 plus sine of x from x equals 0 to x equals 5 about the x-axis, all right, where x and y are measured in inches. What is the volume in cubic inches of the vase? All right, well, first of all, and we really don't, if you know what you're doing, you really don't need a visual, but I'm going to give you a visual anyways. I don't know. I don't care what this graph looks like. I mean, I could graph it. But from when x is 0 to when x is 5, we got something. If it looks like a vase, maybe it looks like this. Like that. I don't know. Here to here. Okay. Area under the curve, okay, is integration. We don't want area, we want volume. And it's going to be revolved around the x-axis. So I'm going to take it, I'm going to revolve it around the x-axis. So this would kind of come down, up like that. Okay, they want this volume. I'm going to use circles. Okay, the area of my circle, and I'm going to add up all these circles together. Okay, in order to get volume, I need to integrate. Okay, volume is when I integrate area. Don't forget your dummy variable. And I'm going to do that from 0 to 5. But the area of the circle is pi r squared. The radius, okay, the radius is my function. Whatever value of my function is here. That's my y value, or it's 2 plus sine of x. All right? So the area is 2 plus sine of x. That's my radius. Remember, I got to take the radius and square it. My dummy variable. Pi is a constant. I'm going to put that on the outside, and I want that from 0 to 5. All right? Great thing. It's a great, great thing that we get to use a calculator. All right? And all we're going to do is just put this right in a calculator and press enter. Love it. Okay, so there we go. 2 plus sine of x squared. Turn this bad boy back on. Clear. We will go math number 9. Well, before we do that, let's put our pi in first. Now math 9 from 0 to 5. Parenthesis 2 plus the sine of x. Parenthesis, parenthesis. I need to square this. That's the radius. But my area of a circle is radius squared. Make sure you have a closing parenthesis for every open parenthesis. Sometimes that'll give you an error if you do not. Okay? I see right here 1, 2, 3 open parentheses, so I should have 1, 2, 3 closed parentheses. I do. 80.115. We'll call this a 5 because the number after it is 5 or bigger. So 80.115. Let's get rid of this. Look at that. Perfect. It is choice E. You know, it's rare that I get a problem that has a table, graph, or chart that I love, but I really dislike. Let's go over this. I love the setup, but I really don't like the solution. And I'll explain when we get there. Number 80. The table above gives selected values of the function f. The function is twice differentiable, with the second derivative always being greater than 0, so it's always positive. Which of the following could be the value of f prime of 3? All right, well, I mean, I don't know. We can't find the exact value. Let's go gray here for a second. Let's go gray. Yo, that's pretty. Okay, so f prime of 3, here's f. So remember, f prime is really the derivative, which is the same thing as the slope of f at an x value of 3. All right, I have this. And we're taught that we should get the two closest points and just find the average value. So I'm going to do my change in y over my change in x of the two closest values that sandwich 3. So I'm going to use where x is 1 and x is 5. So I'm going to take, we'll start with this one, 5.4, we'll call this y2, minus y1, which is 2.4, all over 5 minus 1. I end up with 3 over 4. I don't need a calculator for that, which is 0.75. I don't see 0.75. And this is why I don't like this problem. Which of the following could be the value of f prime of 3? It's this one right here. It's that one right there. Okay, again, I don't like it. But, you know, what are you going to do? What are you going to do? That's the answer. And it bothers me that they wrote a question like that. Number 81. At time t equals 0, a forest preserve has a population of 1,500 deer. That always seems to be important. At time 0, we already have 1,500 deer. If the rate of growth of the population is modeled by R of t, which is 2,000 e raised to the 0.23 t deer per year, what's the population at time 3? All right, if I want the total number of anything, I can integrate the rate to get the total number. So if I integrate R of t dt from 0 to 3, it will add up all my deer in this rate from time 0 to time 3. But let's not forget, let's say here's time 0. We go all the way to time 3, and we add up all these deer. Okay, we're just adding up the deer here, but we still need to take into account we already had 1,500 deer before we added this up. So we need to add 1,500 to that value, because at time 0, before we did any adding, we already had 1,500. And then starting at time 0 to time 3, we add up all those deers to that 1,500. All right, let's go. Let's put this in the calculator. Turn this on. Okay, get rid of this. We're going to take 1,500. We're going to add it to math 9 from 0 to 3 of our RT. And that was 2,000 E raised to the 0.23 X dx. Boom. And your answer should be 10,141. Bring this out. 10,141 is choice D. All right, pretty simple one. You just can't forget to add the deer we already had at the start. Oh boy. Have I mentioned how much I love tables and charts and graphs? Oh my. Number 82. The figure above shows the graph of f prime. All right, wait. I got to do something. Y is f prime. I know they put it down here, but all these y values represent the value of the derivative. I have to do that, okay? So the figure above shows the graph of f prime. The derivative of the function f for values of x between -6 and 8. Of the following, which best describes the graph of f on that same interval? And as I look at my choices, I see it says something about a relative minimum, a relative maximum, and points of inflection. All right. First of all, we know at this point we need to find the minimums, the maximums, and the points of inflections. Let's focus on the mins and maxes first. Okay, so mins happen when my first derivative goes from negative to positive. I don't know, I put the minus sign, then wrote out positive. Negative to positive. Maximums happen when my first derivative goes from positive to negative, okay? So let's first look at that. And that typically happens at critical points where my first derivative is equal to 0. So first derivative is 0 here, here, and here. So let's figure out if the first derivative changes signs at those zeros, so to speak. Now, again, the first derivative is the y value. Anything above the x-axis is considered positive. Anything below the x-axis is considered negative. So as I follow my graph left to right, positive y values means positive first derivative. Okay, 0, then negative. All right, well, it goes positive to negative. That means I have a max there. That's a max point. Right there. So I have one max. Okay, so let's keep on going. I go minimum. I hit 0 again, but then it stays minimum. So that is not a min or max because my derivative, f prime, the sign did not change. Okay? So let's keep on going. Minimum, 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 minimum. Another 0. And now it changes to max. Or excuse me, changes to positive, from negative to positive. So if it changes from negative to positive, that means I have a minimum right here. There you go. All right. So we have one min and one max. So let's look. And choice A and B are the only ones that say one min and one max. Because choice C, D, and E say two minimum, two minimum, two. These can't be it. So it's either A or B. So now let's go on to the points of inflection. All right. The points of inflection are the second derivative. Okay, so the second derivative. The second derivative, a point of inflection, all right, is where my first derivative, okay, changes slope. Not sign, but changes slope. Because the second derivative is the slope of the first derivative. All right? So what I'm going to do is I'm going to just erase this beautiful marking right here. And now my pluses and minuses aren't going to represent the value of the derivative. We're going to look at the actual slope, okay, of this graph of the first derivative. So here we go. This is a negative slope right here. Negative slope is going downward, 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 boom. Slope is 0. Yeah, the green one. Now it changes. We've got a positive slope, 0 slope again. Back to a negative slope, 0 slope again. Back to a positive slope, okay? So my slope changes 3 times. You might say to yourself, well, this is kind of like, this is almost a 0 slope here. Even if it were, I still have a negative slope, and it continues to be negative. It does not change. Okay, we want to look where my slope changes. It changes at 3 spots. Here, here, and here. Here it does not change slope. So choice A tells me 3 points of inflection, and that's your answer. 2 more problems. Let's go. 83. Let f and g be continuous functions such that the integration from 0 to 6 of f of x dx is 9. The integration from 3 to 6 of f of x dx is 5. And the integration from 3 to 0 of g of x dx is negative 7. What is the value of the integration from 0 to 3 of 1/2 f of x minus 3 g of x dx? All right, I mean, I could do this really quickly, but I will break it down for the sake of explanation. All right, first of all, if I'm integrating multiple terms here, separated by pluses and minuses, I can consider, like, I can integrate just this separately and integrate this separately. So that's the first thing I'm going to do. The integration from 0 to 3, well, 1/2 f of x. I'm going to take that 1/2 constant and move it to the outside. So that's of f of x dx. Okay? Minus. Now I've got this right here. I'm going to integrate that from 0 to 3. We have another constant, 3. I'm going to put that on the outside of g of x dx. All right. Well, let's state the obvious first. All right. This integration goes from 0 to 3. Here, it goes from 3 to 0, or, you know, vice versa. I should start with the bottom, not the top. This goes from 3 to 0. This one goes from 0 to 3. So I can flip my bounds here, but anytime I flip the bounds, I have to negate my answer. Okay? So I'm going to take this whole thing. I'm going to minus. Now it's a negative 3 integration from 0 to 3 of g of x dx. Okay? All right. Sorry, I felt a little festive there for a moment. Now, f of x, what may or may not be obvious. I want this from 0 to 3, my bounds. I don't have that. I have 0 to 6 and 6 to 3. So if I have from 0 to 6, this whole area under the curve, because that's what integration is, but I really only want 0 to 3, I can take from 0 to 6 and literally subtract this away. So I can take my integral from 0 to 6 and subtract my integration from 3 to 6. It will get rid of this and leave me only with this as from 0 to 3, which is what I want. So that's exactly what I'm going to do for f of x here. All right? So I've got my 1/2. This is going to be breaking down. I'm going to integrate from 0 to 6, f of x dx, and subtract out the integration from 3 to 6 of f of x dx. All right? And now I could put in numbers. I have numbers for everything now. Okay? And if I look up, okay, 0 to 6 is 9. So this is going to be 9. That was given to me. Minus 3 to 6. Okay, we just put this in. 3 to 6 is 5. So I'm going to put this here. 5. And I got to multiply it times 1/2. 1/2 of 4 is 2. Okay. Minus negative 3 times this, my friends, if I go back up, is negative 7. Negative 3 times negative 7. This turns to a positive 21, but don't forget we got to subtract that. 2 minus 21 is negative 19. Didn't need a calculator there. Thanks for putting this on the calculator section. I didn't need it. But guess what? My answer is choice B. If you knew these rules down, you could have done that without any of this explanation. But you're watching this video because you need it explained, and there it is. Choice B. Number 84, the final question we are going over today. The regions A, B, and C in the figure above are bounded by the graph of the function f and the x-axis. The area of region A is 14. Okay, so let's write this down. Region A is 14, so I'm going to put 14 right here. And the area of region B is 16, so I'm going to put 16 here for region B. And the area of region C is 50, so I'm going to put a 50 right here. All right? What is the average value on f on the interval from 0 to 8? Oh, when we first started this video, the very first problem wanted the average velocity. I said, don't mix that up with the average value. Well, this one is an average value. Average value means I'm integrating from some bounds, a function, dx, but I got to multiply by 1 over the difference of those bounds. We have 2 bounds. We are going from 0, my lower bound, to 8. So on my integral, if I go from 0 to 8 here, that means 8 minus 0 goes here. And the integration is really, isn't that area under the curve? It sure is. So I'm going to take the area under the curve and multiply it by 1/8. So I have 1/8 times, be careful, anything underneath the x-axis is considered negative. So it's really a positive 14 minus 16 plus 50. Okay, and I don't think you need the calculator for this. Okay, you should end up with 48 times 1/8, which would give you 6. And that's the, and there were a couple of problems that we didn't need the calculator at all, but there were some that we absolutely did need the calculator for. And that's how these multiple choice problems go. We are done. Don't forget to like, subscribe, follow me, because you will get notifications when I put up future videos. All right? Hey, have a good rest of your day, and I will see you back here when we do the next part, the next 8 questions. Bye-bye.
Don't forget to subscribe and ring that bell.